Welcome to the final video. I'm just as tired of talking as you probably are of listening, but it's all good. We're in this together, so let's just head right into it. If you had an opportunity to look at this second one, great. If not, I would recommend pausing and trying it. If you're not comfortable with that, it's fine. Just hang on tight and listen. Here we go. In following the last video of part 1 of this activity, we saw that the line was translated up, or the triangle was actually translated up. I think it was 1 unit. But now we're still working with those same triangles, except now you notice that it is not just translated up, but it is also translated over. So if you're already thinking what I'm thinking, when we go to create that equation, it's not just affecting the vertical change like it did here. It's also going to affect the horizontal change, and that's what we're going to determine. Okay, so let's get the highlighters out again. I'm going to highlight my vertical change green for both of them, my horizontal orange or yellow, depends on how you look at it. So let's just take these expressions again here. I know that this is 10, 10. This is 10, 7. And they both have in common the 10s for the x value, and it's the y values that are different. So I'm coming up with that expression of 3 by doing 10 minus 7. Same thing if I look at the horizontal. This is 6, 7. This is 10, 7. Now I see that my y values are what they have in common, and it's the x values that are different. So I'm getting that expression of 4 by doing 10 minus 6. But we're not always going to have enough information, so we have to look at creating that rule to figure out whether or not a point will fall on the line. So let's go over here to E. For E, they give me that ordered pair of X, Y. I don't numerically know what it is because now, this time, it's a little bit past 4 and it is also close to 6. And F shares that X value, but I do have more information about the Y value for X because it is lying directly on 4. So I can say this is X4. Okay, now let's think about the shift that happened. So the shift that happened to this triangle is it actually, or the translation, if I'm using proper terminology, went up 4 units. So I have to consider that distance of 4 that was taken away from the origin. So let me get my pen again. If I knew this X value here, the Y value here, I would have to subtract it from the Y value I know here, which was 4, because I had that translation of 4 units. So I would say this would be represented by Y minus 4. If we go the horizontal distance, this was shifted over or translated to the right 4 times as well. I'm sorry, I lied. 2 times. Right here. If I knew what the X value was, which would be represented right here, I would have to take 2 away because I shifted over to the right 2 units. So I would represent this with X minus 2. Now my horizontal and my vertical side lengths, so my vertical change and my horizontal change, are represented by 2 different expressions. So I have Y minus 4 and I have X minus 2. And what does this have to be equal to? It still has to be equal to a slope of 3 over 4. I had some information here. I know that every single time I find an XY value, I have to first take away 4 from the Y, then take away 2 from the X, and I should see it be equal to 3/4. So let's test this out. Okay, so I'm going to take point B, which is 10, 10, and I'm going to use this information right here. So 10, 10 My y value is 10, my x value is 10. So if I do 10 minus 4 and 10 minus 2, I end up with 6 and 8, and yes, that's equal to 3 over 4. Let's try a point that's not on the line. Let's try this one here. Let's try 8, 3. So my x value is 8, my y value is 3, and I'm going to use the rule again over here. This is my rule I came up with to figure out if it's equal to 3/4. So my y value is 3, so 3 minus 4. My x value is 8, so 8 minus 2. And already looking at this, I see this is 6, and 3 minus 4, that's a negative number. That's a -1. This is not, well, that is equal to that, but it is not equal to 3 over 4. So that does not lie on the line. Okay, so overall, we want to focus on creating these expressions because that's really going to help us determine if something is on the line or has the same slope as other values or ordered pairs that we find. Okay, so thank you guys so much for hanging in. I know there was a lot of content that I went through today. At this point, my biggest recommendation is to read through the lesson summary, see if there's any important pieces that you can take away from here. Underline, highlight, circle any keywords that you can. When you are done, your job is to do all the practice problems for lesson 11. I don't have the page number in front of me because this document's different. And I'm not sure how many numbers there are, but you are doing all of them, okay? So this should keep you plenty busy throughout the entire class period, hopefully. And if not, I will have something else for you to work on, or you can check out the Are You Ready for More? Leave questions on your paper. If you are not sure how to do it, it is all good. We will figure it out together on Thursday.